Hello everyone, my name is Vijay Singh and I am the Executive Director of Integrated Bioprocessing Research Lab and also the Founder Professor of Food and Bioprocess in the Department of Agriculture and Biological Engineering at the University of Illinois, Urbana-Champaign. First, I'd like to thank Dr. Gajinder Singh for the invite to present this lecture on public-private partnership to develop industrial biotech in US and beyond. In this presentation, I will briefly talk about how University of Illinois, through its Integrated Bioprocessing Research Lab, is partnering with several startup and multinational companies to bring industrial bioprocessing technologies closer to commercialization.
Economic activity, as it relates to advancement in biosciences, is growing in US. Recent estimates place the value of US bioeconomy at nearly $1 trillion, dollars, and it is predicted to grow to $4 trillion dollars in next 2 decades. Not just in US, there's a growing global push for use for sustainable, recyclable materials based on environmental and net zero considerations. There's intense activity going on at the federal government level to support this booming bioeconomy. President Biden last September signed an executive order funding more than $2 billion dollars to start the National Biotechnology and Biomanufacturing Initiative to support research and development efforts. Department of Defense recently funded bioindustrial manufacturing and design ecosystem or BioMade to foster public-private partnerships in bioindustrial manufacturing and infrastructure development. Department of Defense has several other initiatives in synthetic biology. Other federal agencies like USDA are also playing a major role in this field and allocating funding to develop new markets for bio-based products and industrial biotech. If we look at the breakdown of industrial biotech markets, we see there are four major areas: food bioprocess, agri-biotech, bioindustrial, and bioenergy. Historically, biggest component of industrial biotech has been biofuels. However, it's not the biofuels, but biopolymers, renewable chemicals, industrial enzymes, and food proteins that are expected to grow in double digits for next few years. Let's take a closer look at what is driving this growth in industrial biotech. Here are the main reasons why we are seeing this exponential growth in industrial biotech. Sustainability has become a mega trend, creating a market pull. Producers are seeing increasing consumer demand for bio-based alternatives in specific areas. These include premium items such as fashion and automotive sectors, for which higher costs are less of a barrier to purchase, volumes are low, and companies want increased brand recognition. There's also supply side push. Many bio-based materials are now mature. As technology barriers have been overcome, investment has increased in bio-based ventures. Many oil majors are investing heavily in bio-based materials to build future resilience in their product portfolios. Affordable feedstock. Feedstock makes about 60 to 70% of the total production cost of bio-based materials. There are four places around the world where we can get carbon at a price point where it makes sense to produce these bio-based products. These include for US corn, for South America it's sugarcane, for Europe it's wheat and beets, and for Southeast Asia is also sugarcane. Advances in synthetic biology and metabolic engineering has allowed development of host microorganisms that produce very pure and high concentrations of metabolic products. These products by themselves or in combination with chemical catalysis can produce drop-in bio-based chemicals that are exactly similar to petrochemicals or better in functionality. And finally, positive and supportive regulatory environment. There are regulations that are aimed to increase demand and regulations that aim to increase the supply. These include banning single use plastics or increasing the amount of tax, forcing suppliers to consider bio based alternatives. Because of these reasons, there has been a large number of startups worldwide in precision fermentation. Few years back, National Academies Press released this report on industrialization of biology. This report is available on their website. The gist of this report was that fermentation as a unit operation will play a critical role in production of all kinds of industrial and consumer products in next few decades. This report was published back in 2015 and many of the predictions have already come true related to precision fermentation.
Precision fermentation companies are using design, build, test, learn synthetic biology engineering principles to design host of microorganisms to produce a very specific metabolite with high titers, rates, and yields, and then scaling up these fermentation processes at industrially relevant scales. Next, I'm going to provide examples of several areas where bio-based materials and precision fermentation will play a major role in producing consumer products.
First area is production of biopolymers. Here's a recent report from Start US Insights, which analyzed 532 startups and emerging companies in the space. Some of the major ones are listed here on this graphic, and these companies are producing protein, cellulose, starch, biopolymers, polylactic acid polymers, bio-PET, PHA, and others. These polymers, with very unique functionality, are finding applications in medicine, packaging, agriculture, manufacturing, and water management. Another big area is the renewable chemical market. The total chemical market worldwide is $5.4 trillion. Dollars. Specialty chemicals and materials is about $450 billion. Dollars. And it's estimated that about $130 billion dollars of specialty chemicals and materials market can be replaced by bio-based chemicals using precision fermentation. Biomaterials is another area for precision fermentation. Major brand owners like Adidas, North Face, Nike are all starting to use biopolymers for their consumer products. Adidas with AM Silk has created this 100% biodegradable shoe. North Face with Spiber has produced this moon parka, and Milo bag with bolt threads is producing this leather or product similar to leather with better functionality compared to conventional leather. Cellular agriculture is a precision fermentation based technology to produce milk, eggs, meat, fur, leather, and other ag products traditionally produced by conventional agriculture. Conventional agriculture is challenged by depletion of arable land, increasing cost of water and fertilizers, and environmental pollution, making it challenging to meet the upward demands driven by population growth. Compared to conventional agriculture, cellular agriculture requires 80% less land, 94% less water, and 76% less overall greenhouse gas emissions. Not everything is perfect. There are many challenges faced by industrial biotech industry. These challenges include availability of low-cost carbon, upscaling fermentation, and fermentation capacity.
Upscaling of precision fermentation and other technologies is where University of Illinois is playing a critical role with the Integrated Bioprocessing Research Lab or IBRL. IBRL is a translational research facility. Typically, at academic institutions, we operate with early stage technologies with technology readiness level of 1 to 4, whereas industry operates or considers technology that are at technology readiness level of 7 to 9. There's a gap, which is also known as the Valley of Death. IBRL is helping bridge that gap. In past 4 years, we have conducted over 1,000 different industrial projects with more than 100 different industrial partners. IBRL is a 40,000 square feet pilot plant space with a 10,000 square feet of high bay area. We can very quickly put together an end-to-end bioprocess because most of our equipment is very modular and quick connects are available for utility requirements. At IBRL, we have conducted industrial biotech projects related to food, fuel, polymers, with many different feedstocks from algae, beans, corn, hemp, lentils, oats, potatoes, and wheat. This concludes my presentation on the vibrant industry-academia partnership at IBRL in developing agri-biotech industry in US and beyond.